Business entities around the globe face many challenges in the 21st century. As the technology-centered workplace continues to globalize, the need for skilled professionals is greater than ever. In the United States, for example, some 70 million baby boomers will retire over the next 15 years. At current trends, there will be only 40 million workers to replace them. From a global perspective, it is estimated that between the years of 2010 and 2020, the world will face a shortfall of 32 million technically specialized professionals. Notably, here in the United States, these troubling statistics are becoming even more acute as our colleges and universities struggle to graduate the appropriate numbers of suitably trained new workers. Primary areas of concern include the academic disciplines of science, technology, engineering, and mathematics, known collectively as STEM. In contrast, the countries of India and China graduate 6 and 8 times, respectively, more engineers every year than we do here in America. This growing trend has forced businesses to search worldwide for these highly in-demand STEM professionals. To address this ongoing crisis, IBM has created a program known as the Academic Initiative. The goal of the program is to help train, educate, and accelerate the development of STEM workplace skills around open, standards-based technologies. I recently visited with Dr. Phil Farley to learn more about this growing problem and IBM's commitment to finding solutions through their Academic Initiative program. Dr. Farley travels the country, speaking to universities, businesses, and public policy makers about the issues facing us today and in the future regarding the demand for a technologically skilled workforce. Dr. Farley's presentation, titled "At the Threshold of a 21st Century Business Revolution," gives us the framework for the IBM Academic Initiative.
Things that are driving IBM are those things that are related to resolving real business issues. That's the thing that drives innovation. That's the thing that drives the purchase of new equipment from IBM, whether it's hardware, software, or services. It's this business revolution that we have to make sure the students are properly educated for in order to address the concerns that we see coming up.
Dr. Farley explains that this revolution is forcing a major focus on innovation as companies become global enterprises. This new global trend affects governance, structure, and organization. Geography plays a new and different role as boundaries fade through the use of technology.
We always talked about the death of distance, and we're seeing the same notion of the death of distance. It doesn't matter where people are. What matters are what skills are being performed by people wherever they are. And those skills have to be addressed in a way that will solve all of our customers' real business problems. So the role of geography is changing.
Dr. Farley went on to explain the requirements at the human dimension of innovation, including social skills to work in diverse, multicultural teams, leadership, adaptability, communication skills, comfort with ambiguity, analytical skills and the ability to recognize patterns in disparate data, and understanding how to translate challenges into opportunities.
One of the surprising things is to see the growth in the services area. And when you look at this chart in detail, you see that this dark blue area that talks about an agricultural environment, and the gold area is the manufacturing, and the gray area is services industry. Now, if you look at it within the U.S., about 80% of all the employees in the U.S. are in the services industry. Now, that ranges all the way from the people who will, change the linens in your hotel room, or the people that are servicing your mission-critical information technology systems. All of those are service areas. These 6 countries that I highlight, the United States, Germany, India, Japan, China, and Russia, the rapid growth in the services area in each one of those countries. We expect by 2010, 80% of the worldwide workforce will be in the services industry. And that's a fundamental change. So what we want to do is try to get our arms around what we can do to address that shift in that marketplace.
To effectively integrate globally, companies are utilizing open technologies and nurturing innovation. Job descriptions and employee roles are much different than in the past.
So the kinds of skills that we need are changing dramatically. They're moving from the jobs that are likely to be outsourced by any enterprise. They're moving to jobs that are more mission critical, that are closer to the enterprise, that are related to business analysis or security analysis or how you manage vendors throughout the world. Those are all held very closely to the corporation. Those are jobs that are not likely to be outsourced. It takes a higher level of thinking, a higher level of education in order for students to be able to effectively work in that kind of environment.
As we see a dramatic increase in demand for STEM professionals worldwide, here in the United States, we are seeing a continuing decline in student enrollment in science, technology, engineering, and mathematics majors.
So we have to be able to create programs that will allow women to become interested in this technology and to have underrepresented minorities be interested in this profession. There are a tremendous number of high-paying jobs within the industry that they can fill today and in the future. We're also seeing there's accelerating advances in technology that are driving down the costs of technology. And it's just absolutely amazing to see what is happening to the cost of technology. One of the projections that I read is that by 2020, any person would be able to buy a computer for $1,000 that has the computational power of the human brain. And you think of that power for $1,000, the kinds of problems that can be addressed are problems we haven't even imagined. Global infrastructure is feeding into the global resources and the global production that is enabled by a culture and legal systems that provide that globalization. All of the pieces, in a sense, are falling into place. So we see that this globalization really taking place. Now, the market environment is the one that is also changing. Now, we can discuss the evolution of systems, but when you first thought of this evolution of systems, you think of a computer, and then you have these things that would plug into the computer. You would have storage devices. You'd have printers. You'd have elementary networks that would fit together. And then it grew. The systems became a little bit more complex. That included then a data center. We started getting silos of information. You get business units and departments who would have their own areas of technology. But the systems were becoming complex. Then they became more of an end-to-end enterprise. So you saw the evolution of ERP solutions, where ERP solutions then required a significant IT infrastructure. They required applications that would cross the enterprise, data that could be used by a marketing department, an engineering department, a shipping department. So you'd have data that would need to be shared across the entire enterprise. And then finally, what we're seeing now is this industry ecosystem that is really becoming a global digital economy, and we're talking about marketplace solutions. So we're integrating ERP solutions with other ERP solutions. We're taking all of the applications of the enterprise and integrating them under a common environment. So we have the people, the processes, and the information that are all coming together to feed that industry ecosystem.
Dr. Farley explains this industry ecosystem in another way, using an inverted pyramid with technology at the bottom, then products, applications, and business. This model starts with classic engineering and ends with service science, management, and engineering. SSME is the application of scientific, management, and engineering disciplines to tasks that one organization beneficially performs for and with another. According to Dr. Farley, IBM expects to hire 50,000 new college graduates over the next 5 years in the SSME field.
Some of the major lessons that we've learned is that as engineering has changed, as engineering has evolved, as information systems have evolved, we're able to solve problems today much differently than we did in the past. Now, this graphic that shows the Golden Gate Bridge was engineered 50 years ago or longer. That engineering was much different than the kind of engineering that was used to build a jumbo jet or to build our current satellites. And those engineering tools that are being used today are affectionately known as CAD/CAM tools, computer-aided design, computer-aided manufacturing tools. And they have screens that look much like that graphic. So that evolution of those systems has grown dramatically. Wouldn't it be interesting to think of that technology layer, the smallest triangle at the bottom of that pyramid, that if there was a CAD/CAM-like application that addressed business that would overlay that area of technology, so that business could define their processes in the same way that a double E, an electrical engineer, designed the IT circuits, have continued to evolve. So that would be an incredible solution if we could do that. This is all tied around this modular software component, as we call an enterprise service bus, that is related to a service-oriented architecture. And that's one of the hottest fields in the area of IT today. We've seen the growth in the last 3 years in SOA skills of being over 1,700%. I mean, that's incredible growth in that area, in part because it's a new area, but also because those skills are absolutely in high demand within the industry. So it gives us a way that we can integrate every component of the enterprise into a service-oriented architecture. Social networks is an area that we've seen an awful lot of. The social networks are the things like Wikipedias or eBay or Amazon.com, and it's evolving over time. As we started with what we call Web 1.0, we're now in Web 2.0. While Web 1.0 was about connecting computers and making lots of information readily available, Web 2.0 is people working to people and making the applications better. But we get into Web 2.0, that's not the end of what we're trying to go to. But let me give you a couple of examples that you see in Web 2.0 today. Circuit City has a really interesting pilot in a space that is called Second Life. And this is an environment that would allow an avatar that you create, so kind of your own robot that exists in this Second Life environment that is you. And you can walk up into a Circuit City store and you can point at any of the devices that are in that store and you could ask them the questions about some kind of a video camera. And what are all of the aspects of that video camera? How much is it going to cost? How does it compare with one product or another? And then you can actually place an order online and either go pick it up at Circuit City or have it shipped to you. It is just such a human kind of an interface because you will be interacting with a Circuit City avatar. So you will be talking as you type in information to that avatar, it will evolve till you will be talking voice to voice with that avatar. It's incredible to see how that has grown. But this Web 1.20 is going to continue to grow into this Web 3D area. Where we thought in Web 1.0 that was all access information, finding information, sharing information, that went through all of the industries, like most of the industry. Banking and retail and media and entertainment to procurement, all of those areas that could take advantage of that information. Then Web 2.0 with the invention of things like eBay and Amazon.com and Second Life and MySpace. All of those areas are allowing people to communicate better and better with each other. Now we move toward this area that we think of as Web 3D, and this allows people to not only collaborate, but now to begin to co-create applications. So you're getting millions of people that are working together to co-create applications that fit into all of those areas. Again, addressed to solving real business issues. So all this area of social networking, something that is evolving very quickly, and I think it's really fascinating. This particular slide is a really interesting way to think about innovation, because you think of proprietary innovation and open collaborative innovation as being on two sides of a fulcrum. All of the profit to a company comes from proprietary innovation. So when things are proprietary, people have to buy from that company in order to get that set of features, those capabilities that they would like to have. But they're closed programs, they're introduced to produce revenue and profit for the owner of that technology. When you think about open collaborative innovation, that's creating, maintaining, enhancing capabilities that are shared free of charge. So you see things in the area of open collaboration like this evolution of Linux, which is an open source operating system that has hundreds of thousands of developers. But we have perhaps about 10,000 engineers within IBM that are working strictly in Linux. This is an open source area. We are able to leverage the investment of these 10,000 engineers that we have into the investment afforded by the 100,000 that are participating, because it's all this open source area. So we're able to bring those technologies to bear and be able to then introduce our products that are based in a Linux environment. So it allows us to, in one sense, take advantage of what we have in this open collaborative innovation side into the proprietary side and be able to sell the products that are based on those areas and deliver real value to our customers. What we're seeing then is that the nature of innovation itself is changing. Innovation is occurring more rapidly, it's more open, it's more global, it requires wider collaboration across multiple disciplines. And it's just fascinating to watch this grow. But talent is the driving force, right? It's the people that make innovation happen. Technology can enhance it. Technology is the component that's required for innovation to take place. So it allows us then to be able to allow people to be innovative using the technologies that are available today.
Academic innovation is a key component in supplying the new foundation of highly skilled employees needed to operate in the 21st century global economy. IBM, through their academic initiative, is partnering with colleges and universities to encourage the use of open standards and technologies to better educate millions of students for a more competitive IT workforce. Dr. Farley explains how the program works.
Specifically, what do we provide through this program? First is that we will give all of our middleware and tools to universities for them to use in the classroom. And not only do we make it available to university faculty, we will also make it available for students. So the students can download that software on their own laptops or their own desktops so that they're able to do all of their assignments having that software residing on their own platform. So it's very powerful for both students and faculty to have this all at no cost. We also provide a tremendous amount of IBM hardware for universities to use in the classroom. But we also have a ton of courseware that we make available. Currently we have between 150 and 160 courses that universities can download, and they can use those materials to fit into their own course. But in addition to that, we will also come on site and provide free training for faculty so that they understand how a product is used in industry, how it can be incorporated into the curriculum in general, and how it could be incorporated into a specific class. Now, we also provide these areas of certification, and IBM has hundreds, if not thousands, of various certifications. This is the only thing that students would have to pay for, but they get those at a 50% discount currently. We're looking at how we can improve that, but currently that's at a 50% discount. The thing that is the real benefit of that is not only does that give them some added credibility when they look for a job to say that they're certified in a particular area, but at a student's choice, if they have any of those certifications, or if they can demonstrate that they learned IBM technologies in the classroom, they can place their name on what we call the Student Opportunity System, which is a resume database. And that database is then searchable by IBM business partners and IBM end-user customers so that it can serve as a first filter as they begin looking for new college hires. And I think it's a program that's just now getting off the ground, but I think it is something that will be very well received by both the business community, universities, and students. We have a number of tutorials and articles and our IBM technical papers that we call Red Books that are freely accessible to universities that they can download and use in their classroom. We'll bring people in to take a look at the curriculum, not as an accreditor, but just as, are you teaching the skills that we are hearing the industry tell us that they need? And if not, how can these skills be incorporated into which classes? It's been very successful. And we offer a number of forums and webcasts and newsletters that help keep faculty and students informed.
Dr. Farley went on to explain that companies can participate in this program by letting their recruiters know about the academic initiative and by having them discuss specific needs with the university faculty, serve on industrial committees at favored institutions, volunteer for guest programs and lectures, provide technical guidance, case studies, and projects, and by creating internships, full-time jobs, and scholarships. What I'm seeing here, IBM is really investing in itself as well as the community at large. You're making sure that the students, starting from the very young up through the higher education, gets the training and the education that they need and the skills that we have recognized as the future trends that are going to be needed. And it's going to help those students prepare to come back and make more contributions to IBM and other businesses.
Well, Sue, that's exactly right. And I think it just points out the overall commitment that IBM has to the education community. We have a long history of supporting education at all levels worldwide. And I think this creation of the academic initiative is the latest cog in that wheel. And this is a very innovative and very complete and a very successful program.
Dr. Farley, thank you again for being with us today. We really enjoyed the information you provided for us on the IBM Academic Initiative.
Well, Sue, thank you very much for the opportunity to talk about it.